Children, let's take one more interesting sum. This is very, very interesting, right? Let's see what is the sum trying to say. It says in the figure, in triangle ABC. So we have triangle ABC. Point D on side BC. Mind you, point D is any point on side BC. Point D isn't a midpoint, right? Point D is any point on side BC such that BAC is equals to ADC. I have given the marking also. BAC is equals to ADC, right? What you need to prove is, prove that AC square is equal to BC into DC. I intend to prove AC square is equals to BC into DC. Now children, I would like to give you one tip. One tip has already been given to you in the earlier sums which we have done. What was the technique given to you? Whenever the figure is a merged entity, what we need to do is, we need to demerge it. Very soon we are going to do that also. But in this particular sum, what I would like to say is that, in the previous one also we have done this. Here also I would like to, AC square is BC into DC. That's what we need to prove, right? This is all about CSST. Mind you, this entire thing is all about CSST. When can I get CSST? Once I prove two triangles similar. So whenever we have something into something is something into something, dash into dash is equals to dash into dash, it's all about CSST. Moreover, dash square is dash into dash is also CSST. Only one thing should be taken into account. One care needs to be taken, or you can say one technique is there. When I say that I want AC square is BC into DC, under CSST, what I'm going to get, let me show you in rough. Let me show you in rough. What I'm going to get in my CSST, 1 AC here is equals to, I'll be having something here, mind you, I'll be having something here, is equals to 1 AC here, and I'll be having something here. So once I prove two triangles similar, I have to have 1 AC in one of the ratio as numerator and 1 AC in one of the ratio as denominator, so that on cross multiplying, I shall get AC square. So children, what are you waiting for? What is the second thing? You have to have either BC, DC, or vice versa. If BC is here, DC is here, or if DC is here, BC is here. Are you getting me? So we are always done with, always, mind you, whenever we have dash square is dash into dash, right? So 1 AC square is BC into DC, 1 AC above, 1 AC below. This is what the technique one has to keep in mind. Moreover, we'll take the demerged entity, in fact the demerged figure we'll draw once again. And what is that figure trying to say? We want BAC, or rather it's been given to you BAC congruent to ADC. So what is BAC? BAC is this part entire. So let me draw BAC here. Let me draw BAC. This is my BAC, entire BAC. And there is ADC. So let me draw ADC also. There is ADC. So if I say this is my BAC and this is my ADC, they already have stated that BAC is congruent to ADC. BAC is congruent to ADC. What can you see? What is the other thing? The other thing is nothing but angle C common. As I told you earlier also. Now also I repeat. There are things which will never ever be given to you. What are those three things? First, common side, common angle, and vertically opposite angle. These are the three things which you have to find out from your end. Moreover, common angle and common side will never ever be given to you, right? It is you who have to. So one of the angle being given from their side, one is a common angle. Are the two triangles similar by AA test? And once we are done with proving two triangles similar by AA test, what comes next? CSST, corresponding sides of similar triangle. And I just happened to show you, just before this diagram, I just told you what should be your CSST look like, so that we can get our desired result. Let's start our solution. Let's start our solution, children. I think so we are almost done with our sum here. So we start with in triangle. Which triangle we are supposed to? 1-to-1 correspondence should be taken into account, children. Be very careful with 1-to-1 correspondence. So when I say, let me check this, let me take this only, in triangle BAC. In triangle BAC. Before that, let me write down the given part. Let me write down the given part. What is given? So I'll jot down the given part first. It's angle BAC congruent to angle ADC. Equation number 1, that's given. Equation number 1, that's given. Now we switch over to the two triangles. Be careful when we switch over. One-to-one correspondence should be there. According to me, this BAC, so when I say BAC, then comes ADC, they are working one-to-one. So BAC and triangle ADC, can I say BAC congruent to ADC? From where did I get it? From 1. Next, angle C is common. So what we are writing is angle BCA congruent to angle ACD. Common angle. What next can I say? Therefore, triangle BAC is equals to, similar to triangle ADC by AA test. If you want, I shall write down 1 AC top, 1 AC bottom. This is what we have to have. Let's check whether sir is right or not. So once we have proved the two triangles similar, it's time for CSST. Mind you, there are many children who are thinking about 3 ratios. Dash by dash is equals to dash by dash is equals to dash by dash. But we require only 2. So pay attention from here, where I can get first AC on top and second AC on bottom. Can I take AC over here, then AC by DC? Then I want one bottom AC. So I will take this AC. So I'll get a bottom AC. Now, who is corresponding to this AC? It is BC. Children, are you getting me? I just started off with, I wanted one AC on top. So that's the reason I took AC. So who was the corresponding side? Corresponding side of this AC was DC. Then I told myself that I want one more AC. So this AC over here. And who is the corresponding fellow? BC. CSST. Sir, how about AB and AD? Though they are in proportion, but we don't require it. So I'm not going to take it. I'm just going to write down CSST. Mind you, I have told earlier also. Right now also I'm saying, once again giving you word of caution. You are not supposed to write down CSST shortcut. You are supposed to write down corresponding sides of similar triangles are in proportion. So even if you don't write down R in proportion, just write down right? CSST. Next what? Cross multiplying. AC square is BC into DC. AC square is BC into DC. That's it. We are done with our sum. So what we have learned via this sum, whenever we have something square, that on top equal to that on bottom. So that on cross multiplying, get the answer. So if you want to remember in this way. Always take this as a trademark sum. 1 AC above, 1 AC below. Keep this in mind. Right?